First of all, thank you very much for inviting me to give this paper. It's co-authored with Paul Gao, who's sitting right there, and Jida, who's back at Notre Dame teaching semester for him. Both Paul and I and G as well are finance faculty at our respective schools, North Carolina and Notre Dame. So it's actually a real pleasure that Peter invited us to this conference, because this is, I think, an accounting paper, and I would really value your feedback, either online at the questions or offline afterwards. I actually really would appreciate your feedback. And by the way, before I start, the version of the paper that's in the book is a little bit old. Lori is actually passing out a newer version of the paper. The version, I think, in the book says very preliminary and incomplete. Lori is passing out a preliminary and incomplete version. Perhaps the next one will be just a bit preliminary and incomplete, and then finally complete. So please get those as she passes those out. The first slide I was thinking about putting up was going to motivate the idea of forecasting firm fundamentals, but since this is a conference about forecasting, I thought that slide was not necessary. Instead, I'm going to motivate the talk today by the new variable that this paper brings to the table, and that is search, or search volume. So when we think about searching in a search engine like Google, it's clear that search queries reveal the intentions of those who query. So there's a very nice paper by Hal Varian, who is the chief economist at Google, and Hyun Choi. They have a nice quote. This is, query data may be correlated with the current level of economic activity in given industries, and thus may be helpful in predicting the subsequent data releases. So they have the idea that, well, if search data are correlated contemporaneously with economic variables, in the situations where we observe economic variables being released at a lag, search data may be very good at predicting those lag releases of information. Well, as you all know in this room, firms announce earnings 4 times a year with a lag, right? And so what this paper is going to think about is the possibility that search data may be well suited to predict lag releases of firm fundamentals. So let me just give you a brief summary of what we find. First, we find that the search volume index, this term SVI that I'll be throwing around for the talk, I'll define it in a couple of slides. But you can think of it as the level of search for a given term of a firm's most popular product is strongly related to the revenue announced by the firm, strongly related to revenue surprises. Increases in search volume index lead to positive revenue surprises, and decreases lead to negative revenue surprises. They're able to predict those. That predictability, although it's much stronger for revenues than it is for earnings, which is intuitive because we think search might be correlated with demand, which would show up in revenues, and less so with costs, that predictability also extends to earnings, whether you define them in the time series way or in the analyst way, which was discussed by Mark and company a second ago. We also find that innovations in search volume index, like I said, predict analyst surprises, and that this is especially strong among firms with high information uncertainty, as defined by or as measured by forecast dispersion. Perhaps the most interesting, I think the most remarkable result in our paper is that SVI actually predicts announcement window returns, even after controlling for the contemporaneous revenue and earnings surprises. So the increase in search volume that happened, let's say, in the last quarter of 2009 will predict the return around the February, let's say, earnings announcement of the results that happened back in the last quarter of 2009. So this suggests that there's value relevant, in fact, information contained in SVI that's incremental to other fundamental information about the firm. So I think in summary, hopefully this paper at least gets you somewhat excited about using search volume or thinking about search volume as a value relevant leading indicator. Okay, so in terms of our contribution, we're certainly not the first paper, as you all know, to suggest a non-GAAP leading indicator. Most non-GAAP leading indicators come from the firm, right? There's some clever ones. You'll see Feng present in a moment. The linguistic or textual content, let's say, of firm press releases is used as a leading indicator. information about firm patents or order backlogs. There's a very cool paper that came out of Duke recently that uses the negative affect in a manager's voice as he's talking in a conference call as a leading indicator, and so on. What's really, I think, unique about our leading indicator is it actually comes from not the firm, it comes from the customers, right? Imagine a firm called Apple Incorporated that sells iPods, right? Suppose it sells 1 million iPods. Well, if I buy an iPod, I know about my own iPod purchase, but I may not know about the other 1 million minus 1 purchases, right? Apple knows likely about most of the iPod purchases, and therefore it's very natural to think about leading indicators coming from firms, right? How managers talk, what they write, and so on. What's very nice about search volume is it solves a coordination problem. I know about my own iPod purchase. Trevor knows about his. Paul knows about his. Search volume actually coordinates all of that information together, right? And so and it also has these additional benefits. It's available in real time. I'll show you where you can get it. When you go back to your rooms later tonight. There's fewer concerns about bias and selective disclosure, right? So leading indicators that come from firms, well, firms, have a tendency to selectively disclose. They may have bias disclosures and so on. You're less likely to get that in a leading indicator that actually comes from the customers, that coordinates the customer information. And this may be especially useful when, perhaps even for firms, when they have very little information. I'll give you an example at the very end, which hopefully solidifies this idea. There are a couple of papers that are close to ours. They look at web traffic and profitability among internet firms. What's going to be different about ours is a little bit broader in terms of the firms that we can look at. In our sample, we have airlines and restaurants and drug companies and so on. It's just not e-commerce and internet firms. And search also doesn't require a customer to visit a particular firm website, right? Search is the portal by which people enter a set of websites, right? If I was interested in buying a Ford, I actually bought a Nissan lately. I actually never went to Nissan's website, right? But I did type Nissan in the search engine. I got reviews about it and information about test drives. I watched a YouTube video and so on. Went to the local dealership and I purchased. We don't require that the search volume doesn't require that individuals visit, for example, firms' own websites. Okay, so that's another nice advantage. There has been kind of a growing literature that started to think about these advantages that come from search volume. One paper is a paper by the same by us three as well. Over in finance, where we use search volume for stock tickers like MSFT or AAPL as a way to measure retail demand for shares, and then use that measure to predict short-term price movements. It appears particularly useful around IPOs and among small stocks. And then there's also this very cool paper that came out a couple of years ago in the journal Nature. What these authors do, Ginsberg et al., they come up with 45 search terms that are related to the flu. They ask, what would people search if they were about to have the flu, or they thought they might have the flu? Well, they might type in flu or flu symptom or flu remedy, things like that. And because Google can see the IP address of those that search, they know whether that search volume is coming from Wyoming or North Carolina or Indiana, wherever it may be. And what they showed is that they could actually use the search volume for these flu-related terms to predict flu outbreaks about a week or two before the Center for Disease Control could predict them. So a very nice, very cool, I think, health science application. And there's a nice quote from the paper, which I think is useful for motivating this talk. Harnessing the collective intelligence of millions of users, Google Web Search Logs can provide one of the most timely, broad-reaching influenza monitoring systems available today. Okay, so first let me define for you what search volume index is. Google makes the time series history of search volume publicly available on 2 websites. You can get it at Google Trends or Google Insights. You go to Google Trends. Here's a search in Google Trends. You type in a particular search word. I typed in the word diet. And what we'll do is it'll give you a time series history of search volume for the term diet. Each one of these bottom. Thank you. Each one of these points here in blue is weekly search volume scaled by the time series average of weekly search volume. And what you can see from this kind of silly example is that search volume, I think, tracks time series variation in demand for dieting pretty well, right? You can see every year, throughout the year, people become less interested in dieting. Around the holiday season, they really aren't interested in dieting. And then at the first of the year, like clockwork, every year, everybody's interested in dieting, right? And then search volume maps that actually quite well, right? We actually, because we're trying to predict earnings, we're interested in demand for firm products. And so to handle that, what we do is we gather data on firm products from Nielsen Media Research. So there's, we struggled with this for a while. We weren't sure, what were the databases, what were the kind of available data that could tell us for every firm in CompuStat what are the list of their associated products, right? That's not in CompuStat or CRIS, but Nielsen, because they track advertising of firm and firm products, has a list of firms and their associated products. And so we purchased that list from Nielsen. So this is a list of all firms which advertised a product on television during 2004 through 2008. This list had about 9,800 firms on it, which we hand-matched to the set of firms which are publicly traded. And this results in a list of about 865 firms. Now, that suggests that most of these firms, and most of the firms I think that you see advertised on TV, are in fact private firms. I see the law offices of James Sokoloff all the time telling me how well he'll represent me. Empire Today sells carpets, City Mattress. All these are private firms which are in the database but are not matched to CompuStat GV keys. And there are also a host of nonprofit organizations in there as well. Okay, these 865 firms, according to Nielsen, are associated with about 12,259 brands or products. Some firms have an enormous number of products. So one firm, Time Warner, has 886 products in the database. This ranges from magazines like People to home videos such as the DVD box sets of Friends and The West Wing and so on. As an alternative, LoJack only has one product in the Nielsen database. It's the LoJack security system that you may have heard of. In fact, of our 865 firms, 337 are actually matched to just one single product. Okay. To make the data collection process manageable, what we do is we take each firm, and according to Nielsen, based on advertising, we select its most popular product. So we're not going to search for 12,265 products. We're going to take each firm, map it to its most popular product, and run 865 searches. Once we've done that, the next kind of question is, how might those products be searched? So in the Nielsen database, the product names often involve some specificity that perhaps someone searching wouldn't use, right? And so what we do is we ask two RAs to report how they would search for a product in a search engine. And where there are differences between the two reports, we use a function in Google Insights called related search, which tells us online how people search for particular terms. So here's what we have. We have a resulting database, which is a list of firms and associated search terms of their most popular product. Let me give you an example just to nail down the intuition. First, here's an example. Here's a random sample of about 75 of them. First thing you'll notice is about half or so, maybe a little bit more than half, the search term is just the firm name, right? So take, for example, Home Depot, right? Home Depot, its related search term is just Home Depot. Home Depot sells a lot of products, but their major brand is just Home Depot itself, right? That's not true of every firm, of course. Research in Motion, for example, its most popular product is a phone called BlackBerry. Evercore Partners, no one searches for Evercore Partners, but a lot of people search for National Enquirer. Its main product, CEC Entertainment, no one searches for that. Most people search for Chuck E. Cheese, which is its most popular product, and so on. So we have a list of 865 firms and their associated product, or most popular product. Just to give you an example, I took Chuck E. Cheese and I put it into Google Insights, and you can see here's the time series variation for search in Chuck E. Cheese. If you plot this variation with earnings, When you plot this variation with earnings, you see, and it's a well-picked example, but you see that search for Chuck E. Cheese and earnings seem to move quite well. But of course, this is just an anecdote. That's not it's not a regression or anything like it, and so more analysis is needed beyond the anecdote. So the first major table of the paper relates revenue surprises to changes in search. So here's how we're going to measure changes in search. The fiscal quarter that's of interest. We have weekly SVI in each week of that quarter, and we take the average of the SVI in that quarter. And then when we look at changes, we're going to look at log differences between that quarter and prior quarters. Okay, so that's going to be that variable SVI change. That's that top independent variable. The dependent variable here is revenue surprise. For panel A of table 3, revenue surprise is just defined as this quarter's revenue minus last quarter's revenue divided by a standard deviation over the last 8 quarters. We're going to do seasonally adjusted revenue in the next panel, and what you can see is that SVI change is highly correlated with revenue surprise. Here, about a 1 standard deviation increase in SVI change is correlated with about 20% change in revenue surprise. And you can see as you add control variables, standard controls like size or markets book, turnover, and so on, the relationship remains pretty steady. Because I made this point earlier of highlighting this is a leading indicator coming from customers and not from firms, we thought it particularly useful to include leading indicators that come from firms. So here, from the first call database, we have the number of the counts of the number of negative, neutral, or positive guidance that the firm gives before the earnings announcement. The coefficients here go exactly as you might expect. When there's negative guidance, you see smaller revenue surprises, and when there's positive guidance down here, you see larger revenue surprises. Okay. Now, this may not be too impressive to you. Of course, in the last quarter of the year, the last calendar quarter of the year, Apple has a lot of sales in the holiday season, and of course, search volume for Apple's products is very high in that last quarter, right? What might be more useful would, of course, be a seasonally adjusted model where you can tell me that search volume predicts whether this holiday season will be better than last holiday season, right? And that's the bottom panel of table 3. So now the dependent variable is seasonally adjusted revenue surprises, where we have revenue of the current fiscal quarter minus 4 quarters ago. And what you find is that SVI change remains a very strong predictor of that kind of revenue surprise as well. Does this extend to earnings surprises? The answer is yes, but the effect is weaker. The effect is noticeably weaker. I hope this makes some intuitive sense, right? We might think search should be related to demand, which should show up in sales, and less related to costs, which are going to be between sales and revenue, sales and earnings. And but we do find that when you define SUE, this is a time series definition of SUE. So earnings this quarter minus 4 quarters ago scaled by price. SVI change defined as SVI in the fiscal quarter minus 4 quarters ago. The log difference from 4 quarters ago does predict SUE, even after including a host of controls like the ones I mentioned earlier and lag SUE as well. Okay, analyst surprise. We find an interesting result here, which is that, again, we find when you define the earnings surprise based on the median analyst forecast, we find a positive relationship between SVI change and analyst surprise. But when you cut on whether the forecast, the analyst forecast was subject to low dispersion or high dispersion, which papers like Diether, Malloy, and Sherbina argue is a measure of information uncertainty, you find that SVI change, where SVI is really particularly useful, is among the high dispersion firms, where there's more information uncertainty. And as I kind of alluded to earlier, perhaps the most remarkable result in the paper is the predictability for returns. So here again, we're using the SVI change. Again, there's no look-ahead bias here whatsoever. We're calculating SVI change as the average, the log difference coming from the fiscal quarter of interest minus 4 quarters ago. And here the dependent variable is the abnormal announcement return. This is defined as in Livnat and Mendenhall and in other places. You take each firm and find its book-to-market and size-matched portfolio, right? Take the difference between those two, call those abnormal returns, and then accumulate to get cumulative abnormal returns, right? The standard definition of CAR. So these are three-day announcement returns as the dependent variable, and they're in basis points. So how might you interpret this coefficient on SVI change? A 1 standard deviation increase in SVI change corresponds to about 20 basis points, 20 additional basis points over this 3-day period. You annualize that, it's about 17% annually. So it's a non-negligible effect. What's really, I think, quite striking is it even holds, this predictability holds even after including the information that was announced at the earnings announcement as measured by the current SU, the current quarter SU, or the current revenue surprise. The effect with SVI change holds, which suggests there may be information in the search volume which is incremental to the information in SU and the revenue surprise. Okay. Doing okay in 2 minutes? Okay. So just to conclude, this paper finds evidence that search volume predicts revenue and earnings surprises as well as announcement returns. To us, that suggests that search volume may be a very valuable leading indicator, which people have not recognized. What I think could be especially useful is future work, which might identify those key situations in which search volume may be most helpful. So what are the kinds of situations where an analyst might find search volume particularly helpful? Well, one possibility is new product launches. So I give an example here. In December of this year, Nissan is going to launch the first mass market all-electric vehicle. You'll be able to charge it like you charge your phone. Okay? It's going to come out in December of 2010. If you read kind of analyst commentary and more pundit commentary in general about that release, there's an enormous amount of uncertainty about how many units Nissan will sell, right? Now, can they look at past sales of the Nissan Leaf? No, they can't, right? Because it's a new product launch, right? This may be the kind of situation in which search volume is extremely useful. Just like the flu example, it's not someone who's gone to the hospital yet, but it's someone who's thinking about going to the hospital, right? It's a very nice leading indicator of an action to be taken later, right? So to give you an example how this might work if you were an analyst for Nissan, in the fiscal year of 2009, here I plot Nissan's 4 best-selling cars. So the number 1 best-selling car in terms of sales volume is the Nissan Altima. It sells about $2.4 billion. Then the Maxima, then the Sentra, and then the Versa. If I showed you the search volume picture for those 4, Google Insights allows you to do relative searches, so I know how much search one car gets relative to the other. The relative search would line up exactly like the sales figures. Okay, so number 1 most searched is the Altima, then the Maxima, then the Sentra, and then the Versa. And you can get the idea how the analyst might use this information, right? We know search volume up until December of 2010, right? Search volume, we can calculate it today. Maybe the search for Nissan Leaf comes in here, maybe it comes in here, or maybe it comes way down here, right? That information might be highly useful to an analyst who's forecasting something that's extremely uncertain, which is the sales of this new product, right? So I think there's a lot of potential for search volume, and there's just one example. Thank you very much. I'll stop there. Thanks.
What I was hoping was that you'd actually show us what the search was for New Leaf.
Yeah. So if you take out the spikes, it's about here. It's very close to the bottom. Very close to the Versa.
Okay.
Yeah.
One of the things that popped into my mind when you mentioned that you got access to the Nielsen data is the fact that I think search volume is not just random and exogenous, it's actually driven by advertising.
Sure.
So if I advertise a lot either on the internet or on TV or in magazines, that's likely to drive search volume. And it might be interesting to see what the causal determinants are, and again, this might be from the Nielsen data or otherwise, what is causing the search volume. And
Right, but I would also flip kind of your argument on its head and say that's definitely true that search is endogenous to things like a news report or firm advertising and so on. But search gives us, I could take a database, let's say, of Dow Jones news reports about different firms. Search volume is going to tell us which of those news events really drive people to go demand that news or that firm or that product, right? So you can definitely get a database of advertisement or news, but search volume is going to tell you something very specific, which are the set of news events or the set of advertisements that entice customers or that drive customer search.
Yes, just a suggestion to improve or to enrich your paper further. So you're currently examining the mean effect, right, the increase in revenues. But people also use search engines when they are uncertain about something. So controlling for mean effects, it might be interesting to learn about shift in uncertainty. That might be reflected in search volume.
Okay, that's a nice idea.
Go ahead.
In terms of new products, so you mentioned Ultima and Varsa and all that, and then Leaf comes out.
Yeah.
And do you expect that by definition for new products, the search volume will be higher? Because it's a new product, people don't know about the product at all, as opposed to Maxima, there are already many other avenues to gather information. So if the search volume becomes very high for a new product, can that correlate to the actual demand, or there could be a false?
No. It's a great question, and I think this is exactly the question the analyst would ask. He would look for the time series history of search volume, let's say, for Leaf. If you looked at it, as I was mentioning to Trevor earlier, you'd see very large spikes that correspond to news announcements about the Leaf. It was just announced that it's going to sell for about $25,000. That was announced recently. And you'll see spikes around those news events. Maybe the spikes are less informative than the kind of underlying base search, right? Maybe removing those spikes would be useful in the prediction. But I think all of this is something the analyst would do in order to predict the number of units that the Leaf would sell. And of course, nothing special about the Leaf. We could have done this about the iPad or Windows 7 or so on, right? Yes.
Hi. Two questions. First, in terms of the way that or the time period over which you measure SVI change,
Yeah.
Are you assuming similar lag time across different types of consumers? For example, if I search Chuck E. Cheese in your example, I might be looking to go tonight, versus if I search Nissan, I might be looking to make a decision over the next
Right.
Quarter, few weeks, months, whatever the case may be. Have you looked at sensitivity in terms of?
No, I mean, if you have a good suggestion about what is the cross-sectional variable I could sort firms on, like intuitively, I get your point. Chuck E. Cheese, if you want cardboard pizza and sugar high kids, you search for Chuck E. Cheese and you go tomorrow, right, or tonight. But for Nissan, you're right. You may not buy. You may not buy immediately.
You could consider looking, maybe industry adjusting, so that you're adjusting across
Okay.
car industry, across restaurant industry.
It's a good suggestion. It's a good suggestion.
Okay, and then just the other question was, I guess when you looked at, you sort of put up a slide and you had Home Depot matched with Home Depot versus you had Research and Motion matched with BlackBerry.
Right.
If you took out the Home Depot type examples, would you sort of have a pure sample where you're sort of getting rid of the people in your other paper that might be just looking up a stock price for Home Depot?
Sure.
In other words, if you just tested on those, would you get even stronger results in this current paper?
Right. You might. The trade-off would be the nice part about Home Depot and JetBlue and so on, where the product is the name of the firm. Those are often the firms that have just one product by how we're defining them. It's just the firm, right? So to the extent that you worry about the Time Warner cables that have 886 products and we're just picking one, that may not be as great. So that's kind of the trade-off. But it's a good suggestion.
Question on the left.
Yeah.
Quick question. I noticed the list of companies includes some of the internet companies, like eBay, Yahoo.
It does.
There's a lot of like e-commerce companies. So have you looked at what, I'm wondering what the result for those type of companies converts to some of the consumer product companies?
Yeah. We have not run it by industry in any kind of way. But your prediction is that it would be stronger for the internet firms.
I'm not sure because people actually use eBay. They don't search for eBay. They go to the website.
Yeah.
So I don't have a prior for those.
Yeah.
Do we have any other questions? Okay, so I have one. Just if you put this in the context of the question about how we should go about forecasting, and to what extent you sort of use time series based models, etc. What would you infer from your work?
Yeah, I mean, in my view, where our work fits in is introducing a new tool, which may be the kind of causal variable that Ken was talking about earlier, and maybe a tool where we're kind of less worried about the incentives of the producer, right? And so that's what I think is very nice about, as I mentioned earlier, about search volume, is that it originates from you and me, right? From a million different customers, right? It's not originating from the firm who may be optimistic or may have some kind of cognitive dissonance, as Ken mentioned earlier. So what I think is nice, I think it introduces a new tool, and that tool to me seems particularly clean.